Hey guys, Mr. Gardner here again. This time coming at you with a mini lesson on two-step equations. So like our one-step equations, two-step equations are going to be handled pretty much the same way. The overall goal is to isolate the variable. It's just that now instead of having just a single step to do, either multiply, divide, add, subtract, we have two steps that we have to do. And this second step usually involves a constant, either a positive constant or a negative constant. So let's look at an example here. So now we have 2x plus 3 equals 9. So if you see now, we have added this constant in. So we don't have 2x equals 9. We have this whole expression here with two terms in it. So to start off, I need to get rid of this constant. If we think back to one-step equations, we know that to move something to the other side, you just use the inverse operation. And so if I'm going to be getting rid of this 3 or moving it over to the other side, all I have to do is subtract it from this side and subtract it from the other side. So just make sure I'm doing the same thing on both sides. So again, we know that 3 and negative 3 make 0, so that goes away, and we're left with 2x equals 9 minus 3, which is 6. Now we're left with a one-step equation. Okay, so the goal is to get it down to a one-step equation. Then you can just do whatever operation you need to undo what's happening to the variable so you can solve for it. So in this case, multiplication. So we're going to divide by 2 and divide by 2. And we can see here that 2 divided by 2 is just going to be 1. And when we have a coefficient of 1, we don't even have to write it because of identity property. And 6 divided by 2 is going to give us 3. So now we get x equals 3. Now again, we always want to check our answers. So 2, we're going to replace the x with a 3, plus 3 equals 9. And again, we want this to equal this. Order of operations says to multiply first. 6 plus 3 equals 9. We're going to take care of this. I get 9 equals 9. And so that's really nice. So next, let's look at another problem. But let's look at one where maybe the two steps involve the variable being divided. So in this case, let's look at n divided by 7 plus 12 equals 15. Now again, we've got the variable being divided by 7 or being multiplied by 1/7, whichever way you want to look at it. And again, we have a constant in this problem. So with our two-step equations, we have to get rid of this constant before we can solve for this variable. So again, I've got a positive 12. I want to get rid of it, so I subtract 12. And I do that on both sides to keep it balanced. That goes away. I'm left with n divided by 7 is equal to 3. And so now I know I got to think about this as what would I divide by 7 to get 3? Or in other words, what do I multiply 3 by to make this number? Okay. So now I'm going to go times 7 times 7. And I know that if I have this times this whole term here times 7, that these cancel, and I'm left with n. 3 times 7 is 21. And so there's my result. I want to check that. So 21 divided by 7 plus 12 equals 15. And again, 21 divided by 7 is 3, plus 12 equals 15. 3 plus 12 is 15, equals 15. My problem does check out. So I want to just move over this really quick. I want to go over what's happening here. So what you have here is you have n divided by 7. And when I'm doing this times 7, it's really like I'm timesing it 7 over 1. When we multiply fractions, right, we do tops by tops, bottoms by bottoms. And I'm left with 7n over 7 is what I'm left with. Let's make all my 7s look the same here. So if I have 7 over 7 and n, then I really have 1 times n, which is really just n. And so that's how I'm able to get to just an n when I multiply n divided by 7 by 7. So here's the math, so it doesn't look like I'm just leaving out steps. So that's how you would do a two-step equation when you have either the variable being acted on by multiplication or division. Let's look at when we maybe have variables on both sides of the equal sign, what we do here. So let's say we have 4b plus 3, and we're going to set that equal to 2b plus 7. So again, we're going to look at this one. When we have something like this, again, we want to get the variable by itself. So to do that, we have to move these terms around. And it's no different than anything else with a variable. You really just, if you want to get this whole term out of here, you just subtract it out. If it gets subtracted here, then it gets subtracted over here. All we're really trying to do is just undo these parts so that we have b's on one side and numbers on the other side, or constants. So in this case, I'm going to get rid of this 3 from both sides. That's going to go away. I'm left with 4b equals 2b plus 4. Now I wanted to make this term come over to this side. Again, I have 2 b's, so I just want to subtract 2 b's to get rid of them. So that becomes 0, right? That's a 0 pair. This becomes 2b equals 4. And then shout out to Ruby, we're going to divide both sides by 2 here. And we're going to get b equal to 2. Again, you definitely want to check your answer here. So 4 times 2 plus 3 equals 2 times 2 plus 7. So let's see, this is going to be 8 plus 3. This is going to be 4 plus 7. Bring my equal sign down. This equals 11. This equals 11. 11 equals 11. Boom. I know I got my right answer here. Let's just take a look at one more of these ones, because this is really kind of new material, moving variables back and forth across the equal sign here. So let's just look at one more. So let's say we have 11c plus 8 equals 9c plus 20. Again, the goal is to get c's on one side, the constants on the other side, so we get down to a one-step equation. I usually like to take the smaller from the bigger because it makes for easier arithmetic, but you could do it either way you want. You just end up having to either divide by negatives or something else. So minus 8 minus 8, that makes a 0 pair. So I have 11 c's equals 9 c's plus 12. Okay, and again, now I want the c's on this side, so I'm going to subtract them from this side, which means I have to do it on both sides to keep that balance. So here I'm left with 2c, and over here I'm left with positive 12. Okay, so now I just want to divide by 2, divide by 2. This makes 1, so I'm left with just 1c. 12 divided by 2 equals 6, so I know c equals 6. Again, 11 times 6 plus 8 equals 9 times 6 plus 20. Over here I get 66 plus 8 when I do this multiplication first, equals, this should be 54 plus 20. Add these up, I get 74, equals, add those up, I get 74. 74 equals 74, check.